Hello, everyone, and welcome to Africa Fire Mission's weekly virtual training session. My name is Mike. I'm a project coordinator here with Africa Fire Mission, and we're glad that you took time out of your schedules to come and join us for training today. Today's training, we're going to be talking about lithium batteries. Before we get started with that training, though, I'm going to pass it over to Jose, who is Africa Fire Mission's fire safety advocate, and he's going to get us started with a couple words of encouragement.
Thank you, Mike. I truly appreciate you. Thank you for always being around, and also to you everywhere around Africa, from Ghana. I see DRC, I see South Africa. I'm hoping to see Malawi, and of course in Kenya. Thank you so much. We don't take this for granted. Today I just needed to talk about momentum. When you start something, the energy that keeps you going is the momentum. Yeah. When a car starts, it starts so hard, but when you hit the right gear on the highway, it gets so light. Yeah. And for us, I just want to encourage us that when you're in the firehouse doing your work, keep the momentum. Yeah. If you're working out, like today, I was just sent some photos from Muranga Fire Brigade. They were working out, they were busy just keeping fit. I'm just hoping that they can continue with that momentum to keep going so that their bodies can be fit. Company drills in the fire station keeps that momentum going. Throwing ladders, that keeps the momentum going. But you just sitting in the firehouse and waiting for a fire, that's like now when you're trying to push the car to start. But when you're doing something every day, involving yourself in the kitchen, preparing the food, nutritious food, that keeps the momentum going. So even as I talk about that, you need to know that you need to still keep your hope alive. Because even as you start pushing the car to go, it really takes a lot of energy, and you might give up in the middle, go like, this guy is not going to start up, and it is easy for the firefighter to feel discouraged. So keep the hope alive and keep yourself strong, even as you serve God's people. Thank you so much. Back to you, Chief Mike.
Thank you so much, Jose. We always appreciate those words of encouragement from you. As we get started here, just a few reminders. If you stick around for at least 70% of today's class, which is usually about 40 or 45 minutes, you'll receive a certificate of attendance. If you have multiple people watching from the same screen, please email Leah at africafiremission.org, and she'll be able to get certificates for everyone who's attending at your screen. Your screen name that you see on Zoom will be the name on your certificate, so be sure to change that to whatever name you'd like on your certificate. When we get finished with today's presentation, we'll have a tea time hosted by Jose later, where you can ask more questions about today's presentation or anything else that may be on your mind. And during that time, I'll share some information about our Google Drive, where you can get a certificate of attendance for some of the other classes that we've done earlier in the year that you may have missed. So without further ado, we're going to jump into today's training. I want to begin by apologizing. We had a mix-up and our instructor wasn't available for today. So I'm going to jump in and give this a shot. We're going to be still talking about lithium batteries. I've got a presentation here that I've got from New York City Fire Department. So we're going to take a look at that and we'll work our way through this particular presentation. And we've talked about this topic a little bit before. We've talked about the electric vehicles earlier in the year. So we're going to touch on some of those same items again today. But what we'll want to talk about here when we talk about the batteries themselves and how they interact with fire, we'll sort of try to relate that to any lithium batteries that you may find, in other types of equipment, toys, things, whatever you've got there. So let's go with these electric vehicle challenges here. And there's so many different types of electric vehicles. that are out there, or lithium battery powered equipment, right? So we've got hybrid vehicles, we've got full electric vehicles, hybrids that you may have to plug in. When we look at different equipment that's powered by lithium batteries, we have things all the way as small as the vaping devices, bicycles, the hoverboards, the sort of electric skateboards. So there's all of these different types of equipment that's available with these batteries, and they all are just a little bit different. In this presentation, we'll show you some places where you can get some information about how to deal with these vehicles. There'll be a link or two on here, and I'll try to get those links into the chat later on for you. Of course, we'll post this presentation as well on our Google Drive so that you have this information as well. Emergency response guides, the ERG, any type of hazardous materials that you may have. This is the guidebook that we use in the US. For those of you in Malawi, we handed out those guidebooks for you that just teach you, give you some information about different hazardous materials. There's also these rescue data sheets that are available. I would encourage you all to get online and do some searching online. A good search term to use is first responder and electric vehicles, or first responder rescue data sheets. Try some of those keywords and you'll find a bunch of different resources that are available out there to show you some of these guide sheets. They're available for most of the electric vehicles. And they show you where the electrical systems run through those, how to disable them, a couple things that are available there. They're great resources to have. You can find those some various websites, including the manufacturers who make those vehicles as well. I know Tesla has a really good page for first responders with all their different types of vehicles. Websites, NFPA, the National Fire Protection Association, based in the US here, has emergency response guides for electric vehicles. You can see at the bottom of the slide here, there's a link. If you search for alternative vehicle emergency response guides and letters NFPA, you should be able to get to this website where they have some different information. Also available through NFPA, you may find some different training courses that are available if you'd be interested in trying to take those. Some of those are online courses. Of course, the guides that they have there for the different vehicles, those are all free to download for anyone who can access them. Here's a quick look at some of those emergency vehicle guides that they have. This particular one's for Tesla. Tells you a couple things to do, gives you your table of contents, tells you to chalk the wheels. That's really an important thing that we need to do with electric vehicles. You can't tell whether there's an engine running or not, so those are always available to move if somebody bumps the accelerator. Of course, in that vehicle's in gear, it's going to move on you. And sometimes they shift into park a little bit differently. If you see there on the stick, you've got to push a button on the end of the stick there to get that particular Tesla Model 3 to shift into park. So these emergency response guides, they show you all those different information, all sorts of good stuff. Encourage you to seek those out, take a look at those. Your phone is really one of your best reference materials that you're going to have here for these. There's so many different vehicles, they're changing so often that to try to download this stuff, to try to print this out and carry paper copies of this probably isn't practical for you all. So try to find out these resources and bookmark these websites so that you can access them quickly on your phone in case of an emergency involving one of these vehicles. Another look at some of the pages from this. You can see it discusses firefighting, what you should do, how to stabilize the vehicle, how to disable a high voltage system, all sorts of good information there. How do we know if we're dealing with an electric vehicle? There's a couple of different clues, but the first thing we need to do when we're dealing with these type of equipment is determine that's what we're dealing with, right? So there's a lot of different ways to look at it. Looking at the badging, a lot of times there'll be a lightning bolt, or they'll say hybrid on them. They'll say electric on them. They'll have the EV letters on them somewhere. Exhaust, if there's a vehicle that doesn't have any visible exhaust pipes, that's a good clue that you're dealing with an electric vehicle. Some of you all just use the knowledge that you've got, right? Your life experience that you've seen these things. I think a lot of us may be able to pick out those Tesla. They're sort of a unique shaped vehicle, right? We're getting so many of those in the area right now. It's amazing how many we see out on the roads. They're pretty easy to see. Noise, right? Is the vehicle running? Is the vehicle moving but not making any noise, right? Great clue that it's an electric vehicle. And then also those charging ports. Does it have some sort of a charging port? If you open what you think is the gas cap, and there's no gas cap, but there's an electrical receptacle there. Another great clue that we're dealing with an electric vehicle. Just a couple examples here. When you pop the hood on some of these vehicles, if you notice in the picture here on the right-hand side, you can see that bright orange cable. Those are going to be your high voltage lines running through your vehicles. Most all vehicles that electric vehicles, their high voltage system is in those heavy bright orange cables, so that it's easy for you to recognize those as you're looking at them. Okay. Some of the questions here when we deal with these electric vehicles, especially the electric vehicles, and even when we're dealing with the smaller things, maybe the electric bicycles or some of those other electric devices that use those lithium-ion batteries that we're here to talk about today. What do we do about those high voltage chargers that are going to be working? Okay. How do we remove them? What do we do? So let's take a look at that just a little bit here. Okay. Voltages today to charge these vehicles, they run from anywhere from 400 to 900 volts, and that's right now. As we move on into the future, who knows if they're going to have some type of inverter technology or something that's going to jump those volts up much higher. We don't know. And we know that voltages 50 volts or higher, according to OSHA, which is a Occupational Safety and Health Administration here in the United States, 50 volts or more is hazardous. Okay. So what do we do? These are using way more than that. So these are pretty dangerous. What are we going to do? First thing we want to do, disconnect the low voltage stuff, right? If the electric vehicle's running, shut that off, turn off the ignition if it's got a power switch or something like that. Always disconnect the low voltage batteries, the 12-volt batteries, and that's a procedure that we do a lot of times at our motor vehicle accidents that we come across anyway. We're disconnecting those batteries. A lot of times on these vehicles, there's a fire department disconnect for the low voltage. Sometimes it's pretty clearly indicated under the hood. It may be just a little a loop of wire that shows you to cut a segment out of that little loop of wire or something like that. Sometimes there's a fuse that you can pull. It's got a picture. A lot of these have like a picture of a fire helmet on them, so you can identify these as the disconnects for the electrical system. And then if it's plugged in. If it's plugged into a power supply somewhere, remove that, or remove the service disconnect for the power supply that may be charging the thing. Of course, if we're not going to do that sort of thing if we're in standing water, right? So we're going to use all the typical precautions that we would use when we're dealing with some type of an electrical emergency. Here's the low voltage disconnect that I was talking about. You can see there's a little loop there. You've got a picture of the fire helmet, and you actually snip that loop in two places and actually take a segment of that wire out. That's the idea behind that. Don't just cut it once, cut it twice, cut a section out so there's no chance for the ends of those wires to touch. Okay. There's a fuse, the safety fuse there, shows you how to disconnect those on a different type there that you can see on the right-hand side of the screen. So just a couple of different ways. And once again, you can find information about how to disconnect those if you take a look at those emergency response guides for the individual vehicles. A lot of these are going to have, here's your fuses. You can see the various places where these service disconnects are. You can pull those out with the yellow tape. That indicates the ones that you're to use. And then on the right-hand side, there's some other service disconnects. Those are more for the manufacturer for repairs and things like that. It's not necessarily recommended in the field, but if you have some experience with these, I know in Kenya, Jose and I were just speaking before class. He's working on getting you guys some access to some of these electric vehicles. So if you've had the access where you've seen these, you've seen where these disconnects are, don't be afraid to use those as well. There's some different equipment that that's probably not easy for you all to get a hold of, but something to think about. Maybe you've got someone in your fire brigade that before they worked with the fire brigade, they did some electrical work or was an electrician or has some access to some electrician's tools, voltage detectors, different styles of voltage detectors are handy to have, not just dealing with lithium batteries, not just dealing with, electric vehicles, but anytime that you're dealing with voltage and energy. There's some various sticks and handheld devices that you can use to detect voltage. I know there's certain areas that you guys work in where that would be really handy. Throughout Africa, I see a lot of communities that have a lot of illegal electrical connections. So if you can get your hands on any of these voltage detection tools that are available, those would certainly be a great tool to add to your tool set of equipment you have available to you as a firefighter. As we're looking over these electric vehicles, I alluded to it a little bit before in the beginning. The high voltage systems have these orange cabling. Okay, so if you're seeing orange cabling, bright orange cabling anywhere, wiring or cables anywhere within a vehicle, we have to assume that they've got some sort of electrical system in them, and we do not want to cut those. Okay, once again, this is a page out of one of these emergency response guides or rescue guides for these vehicles. So it's showing you the vehicle and it's showing you a layout of where those are, where you can find them. Something else that I alluded to a little bit in the beginning there, unexpected movement. These electric vehicles, there's no way of knowing whether they're going to move or not, right? You can't hear the engine running. So if they've been involved in an accident and the driver of the vehicle is injured, as you try to manipulate them, as you try to move them around, try to rescue them and remove them from the vehicle, if their foot hits the accelerator pedal, right, or what we used to call the gas pedal, sure, that vehicle could start to pull away on you. That's hazardous, right? It can cause danger, it can run one of us over, and frankly, it's embarrassing if the vehicle starts driving away as we're trying to work on it, right? Maybe we have the fire truck parked in front of it, and and the vehicle hits the fire truck or something. So we've all seen videos like that, right? We've got to make sure that we take some precautions to stop that unexpected movement. We've got to put something in front of the wheels to try to block the wheels so that they don't move. Making sure that we put our fire truck somewhere that it's not in the path of that vehicle in case it does move. Of course, beginning the process of disabling the vehicle, checking to make sure if it's in park, those sorts of things. And then there's this interesting device. I don't know that it's readily available right now, but you can see in that top picture that yellow plug that they've got plugged into the port where you would normally plug the charging cable as a safety feature for these vehicles. When the electricity is plugged into the vehicle to recharge it, it disables the vehicle so that it can't move. So this is a new product that they're making available. Should be available now, but of course for you all it may be difficult to get a hold of. But it's an interesting device. It plugs in and sort of makes the car think that it's being recharged. So it disables those safety systems. So that's a really quick way for emergency responders to be able to pop that up and stick that plug in. That may be a ways away for you all. I know if even for us here, we don't have these yet. Okay. Here's that plug I was just talking about. You know, a lot of these vehicles use sort of a universal plug so that you can charge up at any different charging station that's available. So that's how these things are going to work for most vehicles, but not readily available yet. And probably not affordable yet either, but maybe that'll get better in the future. Just be careful where you're placing your apparatus. If it's not on fire, obviously, if it's on fire, right, we need to keep the apparatus further away. Here, they're kind of positioning their apparatus to keep the vehicle from moving. It's an interesting thought. I'm not sure how I feel about that. I think I'd prefer to park my vehicle so it's out of the way of the vehicle so it doesn't get hit. But something to think about, something to consider. Fire involving an emergency vehicle. Okay, lots of different considerations, lots of different things that we want to think about when we have a fire involving an electric vehicle. Here's where we're going to sort of expand our thoughts about this and our consideration of this, not only to just an electric vehicle, but to any type of lithium battery that may be burning, because all of the different things that can take place with the electric vehicle, also you run into those issues with your batteries, as small as your vaping device that we talked about, to a cell phone, to an electric scooter or bicycle or something like that. So anything that's using these lithium ion batteries, all this next bit of information is going to apply. We've got to try to determine what type of battery it is if we can. The old NiCad, nickel cadmium rechargeable batteries of the past did not have the problems that lithium ion batteries have with thermal runaway, which is our main concern we're going to get to in a little bit. And then you've got to look at the type of vehicle, the design of the vehicle, where the batteries are located. Are the batteries located in the undercarriage? They're located somewhere else if it's a large electric vehicle like a bus or something like that. Where is it? You know, is whatever's on fire, is it in a crowded area? Is it in a confined area where there's lots of other homes or there's lots of other vehicles? Is it in an area where there's some open space? With these battery fires, they're difficult to suppress. They take large amounts of water to try to suppress those fires. You all do not have access to large volumes of water. You don't have easy access to it. So sometimes the solution may be to just allow them to burn. So that's more of an option if there's some space available. Okay. Put the wet stuff on the hot stuff. This is, we talk about this all the time. This is typically the simple solution to problems that we run into in the fire service, or if something's on fire, if we put the fire out, everything else gets better. So how do we determine when it's safe to put that wet stuff on the hot stuff? You're dealing with a car fire where the battery is not involved in the fire. It's, the passenger compartment is on fire, like you see picture on the left-hand side of the screen there. Okay, we're going to fight that just like a regular vehicle fire. All the same precautions that we would take, we're going to take. There's no real worries there about electricity or the batteries or anything like that. Go ahead and fight that the way you normally would. If, on the other hand, it's an electric vehicle and we can tell that it's the battery that's on fire, there's where we're going to start to think about doing things a little bit differently. How are we going to attack that fire? We can use water. We're going to use foam. Non-intervention, right? That's what I was talking about before. Are we just not going to attempt to put out the fire? Are we going to let it go? We're going to let it burn itself out? Or full submersion. Full submersion is a technique that's being used, I know, in Europe, where they get these containers where they just put the whole vehicle into a container, fill it up with water, and let the vehicle sit in there. And it keeps the batteries underwater, keeps the batteries cool, right? So, what are we going to do there? The big thing with these batteries, if the batteries are on fire, and the batteries are in this thermal runaway that we'll talk about in a little bit, we've got to cool the battery cells down. So right now, water and large volumes of water seems to be the solution. Now, I do say large volumes of water, but a flow rate as low as 60 gallons a minute. I didn't do the math, convert that to liters for you, but about 60 gallons a minute, a relatively low flow of water can keep those batteries cool. So we don't have to use as much water as we may think to keep the batteries cool, but we're going to need that for a long time. We're going to need to be able to supply that over a long period of time. Okay. If the vehicles are connected to some sort of a charging station, whether they're charging at a home, whether they're charging at some sort of a commercial, at a fueling station or somewhere that has these charging stations, if they're connected to power, before we put the wet stuff on the red stuff or the wet stuff on the hot stuff, we need to disconnect. We need to cut that power off. And at all of these different charging stations, somewhere there will be an emergency shutoff at the cabinet or at the charging station, and should be pretty well labeled, where you can shut off that power before we start to apply water. Same thing if we're talking about an electric bicycle. If we can get to the cord, where the cord is plugged into the wall, and unplug that first before we start to put out the fire. It goes from everything all the way down to a cell phone being charged that's on fire, all the way up to as big as an electric vehicle that's on fire. Those rescue data sheets I talked about earlier that are available, that you can find on the internet, that you can find from manufacturers of the electric vehicles. Those give you some good information about how to fight the fire. It's telling you here, you can see it's talking about a Honda Accord on the right-hand side, a hybrid, right? Telling you how to remove some panels and things so that you can to get water into the batteries and cool them effectively, right? So once again, just a great source of information, these rescue data sheets for you to get a hold of, take a look at, and use those when we get into a situation where those are involved in fire. Okay. Some different options that are available to you when you have a battery fire. And once again, while this presentation is specific to electric vehicles, we can use this for any type of battery fire that we're dealing with. So what can we do to put that battery fire out? Water from our hand line. Okay, applying water from the fire hose directly onto the battery to cool the battery. Probably our first most used one. A large caliber stream that they're talking about. This is what here we would call a ground monitor. This is a large nozzle, a large branch that you don't have to hold on to, that you'll set out and let that discharge large amounts of water. You don't need to be near it. You can position that near the batteries that are on fire or that you need to cool, that may be in that thermal runaway, and sort of stand back away from it. The disadvantage to that is that these types of things use large volumes of water, which is a problem for most of us there, right? We don't have access to large volumes of water. Fire blankets, I see those throughout Africa. I see you guys have those, and that's not something that we really use a whole lot here in the US, but the fire blankets, they can be very effective for battery fires. Excuse me. They make fire blankets large enough to cover cars, and we'll get to some of these. We'll show you some pictures. I've seen you all have some smaller fire blankets that you can use that would be good for some of those smaller things, the cell phones that are involved in battery fires, or the bicycles or things like that. There's specific nozzles that you can use to go under a car, that they're nozzles or branches, as you all may call them, that slide under the car to cool those batteries, very specific for electric vehicle fires. There's also, excuse me, there's also some penetrating nozzles that you may be able to use on certain types of batteries, but they're not appropriate for all of them. And then the submersion that we talked about. Here we have a couple examples of using the hand line. And you'll notice in these how the vehicle's propped up. So we need to get access to those batteries. On an electric vehicle, most of them, the whole undercarriage of the vehicle is made up of your battery cells. And that's what we have to cool. So you can see in both of these examples that they've used something to jack the car up and get it kind of leaning on its side a little bit so they can effectively apply that water underneath. The pros to doing this, of course, it's adjustable. If you've got the manpower and the time, easy to use, right? Once again, though, you've got to be close to the vehicle in order to do this. And it uses a lot of water to try to cool things like that. The fire blanket that I talked about works well. Fire blankets will buy you some time. As you can see, this one is big enough that it covers the whole vehicle, right? You'll just drag this blanket over the whole vehicle. It works, it buys us some time, it contains everything. The idea behind this is that it's going to smother the fire, not allow it to have oxygen, and smother the fire to put it out. The problem with this is we've got to get very close to it, right? Get it right up to the vehicle or the battery so that we can throw that fire blanket over it. And then also you have to understand that the fire blanket, while it'll extinguish the burning parts of the car, it's not going to extinguish those batteries. Those batteries, as they get overcharged or overheated, they go into that thermal runaway where there's that self-sustaining chemical reaction that's going on within the battery that's generating more and more and more heat. The fire blanket doesn't do anything to address the heat, right? It's only removing the oxygen portion of our fire triangle that we always talk about. These are the large caliber sort of unmanned streams, the ground monitors that we talked about. You could set this up to spray on the vehicle, to spray on the battery bank. Probably not a great option for you all. These take huge amounts of water. They use so much water. You'd need to have multiple engines or tenders or Bowsers there, and the ability to shuttle that water and to keep refilling. I'm not sure that would be a great solution at this point in time. This is pretty interesting. These are an undercar nozzle. They're designed to use a very low amount of water. You don't have to be near them. You just take this device, slide it underneath the vehicle, and step back and let it slowly apply those small amounts of water to try to keep those batteries cool, to extinguish or stop the thermal runaway that's going on in those batteries. This is something that maybe you could look into, fabricating something like this on your own, right? If you've got a spare coupling from a hose, you know that you could weld some kind of pipe to it, and you know, drill some holes in that pipe to let out just a small amount of water, misting. This is something I think that you all with some creativity and using some locally available materials, y'all could fashion some type of this undercar branch, whatever we want to call it, for your application. So it's an interesting concept. I'd encourage you to look for some pictures of these things online and see what you can come up with. I know you guys really do a lot with a little, and this would be something I think maybe you guys could come up with if these electric battery fires, begin to become a problem for you all. This is a penetrating nozzle that goes underneath the car. The problem with using something like this, although I mean, this is, to me, even here in the US, this is an inaccessible tool for me. We don't have it. We wouldn't. I don't know that we would spend the money on it. And then the other thing is, because it's a penetrating nozzle, you've got to be very cautious. One of the things that are routinely advised when you're dealing with these batteries is to not break open the battery, don't puncture the batteries at all. And that's the whole idea behind a penetrating nozzle. So I'm not sure this, again, would be a very good option for you all. I don't think it's a good option here in the US either, to be honest. And then here's what we're seeing. You can see in the bottom picture on the right-hand side, some sort of a European country where they've got this dedicated vehicle with this big, we would call it like a dumpster or a big rubbish bin or something, that they're going to unload and fill up with water and put your vehicle in. Certainly that's not an option for you all to have a vehicle specifically for that, right? But the thought about dealing with it is interesting, especially for your smaller batteries. If you've got some sort of a small lithium battery that's experiencing that thermal runaway, it's getting hotter and hotter and hotter. Is there some sort of a container that you can fill with water and drop those smaller batteries in and just let them sit instead of standing there spraying the water? You may be able to do less damage to the area around it and things. So how can we utilize that idea of submersing the battery in water to extinguish it or to let it cool? One of the things I will say, though, is with these, and I'm not sure if we're going to get to that later, not in this presentation, but if that battery is burning and it's off-gassing, the gases that the battery emits as it's heated are toxic, they're flammable. As those are not soluble with water. So if you do have that burning battery submerged, those gases can bubble up through the water and then ignite and continue burning. So you always want to be aware of that when you're using that submersion technique. Okay. After you're done operating with these battery fires, whether it's the electric vehicle that we've been sort of focusing on, or any other type of these batteries, what do we have to worry about after it's over? If the battery's been compromised in some way, if it's been opened up and we've got access to whatever that battery material was on the inside, it was exposed to heat, it was melting, there could be some hazardous material concerns that we have. So we want to treat those batteries as if they're some type of hazardous material. We want to, if we're handling them in any way, make sure that we're wearing our as much PPE as we have available to us. We don't want to breathe any fumes or any of the smoke that comes off of these things. And it's something that we really need to think about, is that these batteries that are involved in fire, when we think we've had them extinguished, they have reignited anywhere from a few hours after we think that the fire's out and extinguished to as long as a few weeks after we think they've been extinguished. There's been some cases of electric vehicles that have been involved in accidents, have had the batteries damaged, that are sitting, at a car park, junked at a junk car park, weeks later, that ignite on fire, because that thermal runaway, that issue with the battery, began at the time of that crash, but it took them weeks for that heat to build up and to continue on until it breaks out into that active fire. So lots of things to think about with those batteries after we're done attempting to extinguish the fire. Okay. If we're dealing with these electric vehicles in enclosed parking garages, and this specifically is talking about enclosed and underground parking garages, you can see the picture on the right-hand side. Just look at the damage done to those vehicles. Look at the floor. You can see the concrete has cracked, spalled, and looks like it's disintegrated and just disappeared, where you just see the reinforcing bar left. So that's telling me that there was a huge volume of heat there, just an intense burning fire. In enclosed places, these battery fires burn much, much, much more intensely because of the different chemicals that are involved in them that are burning, right? So tons of extra precautions when we're dealing with them in enclosed areas. The lack of BAs that are available to you, and the lack of the ability to refill those while you're on scene, throws up all sorts of red flags. So be very cautious. And then if you're dealing with an intense fire, especially somewhere underground in a concrete structure like this, look at the damage that it did to the flooring there. It can do that to the support beams and things as well. So if we've got an intense fire burning a concrete structure that we know we can't suppress the fire, we need to start worrying about collapse. We need to worry about clearing the area, isolating the area, getting people out of the way, and basically expecting that the building is going to collapse on us due to the damage of the fire. And so we want to prepare for that. Think about that as well. And, you know, with the intensity of these battery fires that we see, and knowing full well going into it that we may not even attempt to put this fire out, right? Don't let that be a point of shame to you, that you're not going to try to put the fire out. You're still doing the best service that you can provide by isolating the area, by letting the fire burn out, by protecting the exposures. And then there's where you want to take up that advocacy with your government leaders and things when it's over. If you've got a fire that you don't have the means of putting out, and it's not that you don't have the will or the desire to put it out, but it's that you don't have the equipment to put it out, there's the perfect time to go to those government leaders that you've got and point to that fire and say, look, we were not provided with the equipment to deal with this. You know, we would gladly try to put these fires out, but we can't. We don't have enough water. We don't have enough trucks. We don't have enough ladders. Our hose is in poor condition. All those different issues that I know most of you are facing, a great time to bring those up with your government leaders and do that advocacy portion that we talk about a lot here with the Africa Fire Mission. Inside these parking garages and things like that, if they've got fire protection, if they've got sprinkler systems and things like that, it's probably outdated systems. It's probably not adequate for use with these electric vehicles parked in there, right? So expect that those systems are not going to work, that they're going to fail. You can see there's the concrete spalling that I talked about listed over there, the structural integrity after they're exposed. We're going to assume that it's going to collapse, right? And then, of course, here now it's saying all new parking garages built with charging stations. I don't know that that's really even the case here in the U.S., right? But maybe for New York City, that may be a code thing that they're requiring now. But you're going to start to see if you haven't seen a charging station for an electric vehicle yet, it's coming. It's coming at some point in time for you all as well. Okay. Couple of different apps here listed. Different rescue apps. It looks like a Euro NCAP app. I haven't had a chance to explore these. As I said, I wasn't planning on teaching this class today, So, you know, jot down some of those, snap a screenshot. If you're on on your phone, snap a quick screenshot of this, these names, these apps, so you can look them up and see what they're all about. You know, utilize those phones as best you can to provide you with material. Knowledge is really going to be our biggest tool here when we're dealing with these battery fires. Oh, hey, look at that. That's there we go. This slide confirms what I just said, right? Our best tool is information. And then, of course, we also have these great, we have the Facebook networking group, right? We have the WhatsApp groups that you folks are active in. So if you encounter a fire involving these lithium batteries, whether it's a vehicle, small ones, and it gave you trouble or something like that, get on these groups and share this information with everyone, so that we can all learn firsthand from you guys. What did you do? What did you see? How did it work? That's going to be a great way that we can expand our knowledge as well. If you've got questions about this presentation, you could email this guy. This is the guy that did the presentation, but we'll stop that presentation there. And I think that maybe we covered some things with these batteries. The thermal overload, that particular presentation didn't touch on that a whole lot. So let me just talk about that for just a moment here. You know, so what we've got going on with thermal overload or thermal runaway, it's a problem with these lithium ion batteries. And if they're damaged, or if they're exposed to heat, or if they're left on the charger for too long, that's where we see this thermal runaway issue take place. So what's going on? You've overheated the chemicals that are in that battery, and they start heating on their own, right? And when we talk about our fire triangle, we have heat, fuel, and oxygen. And then if we expand that to now the fire tetrahedron, which is our sort of three-dimensional pyramid, we add that fourth element, which is the self-sustaining chemical reaction. That one really comes into play when we're talking about this thermal runaway. That's where we get this self-sustaining chemical reaction. It just keeps going and going. The heat keeps building and building and building. And then it's setting off more and more of these battery cells. They're heating. That process can take place over a long period of time. That's why we're seeing these fires sometimes break out hours after an incident to as long as weeks after the incident. So that's what that thermal runaway is. That's why we're looking at that submerging technique to submerge those batteries in water so that they just remain cool, trying to stop that thermal runaway, right? So that's the thermal runaway. I see there's a bunch of comments in the chat. Not sure what they all are. Let me, I'm going to allow you all to unmute if you have a question. We've got maybe 10 minutes for some questions, and then I will I'll stop the recording, and then but we'll keep going with the questions, and we'll roll into our tea time. And I see Adelino from South Africa. You have been, that hand popped up a few times during the presentation, so go ahead, sir. Unmute yourself. What do you have to share?
Hello,
or question? Hey, how are you, brother?
I'm good, and you?
Very well. I am very well today. A little unexpected to be teaching, but let's do it anyway.
Yeah, what a nice chapter. It's my first time to learn about battery and everything. We do all hybrid and everything. I just wanted the electrical plug that goes in the ashtray thing. I'm not in the cigarette open up lighter. Does it what do I say? Does it like absorb the electric from the vehicle so that when they do the cutting, it must not, because the moment the car becomes in electric, there is few electrical that are still active in the vehicle. I see that plug. I don't know if does it dissolve the electricity in the vehicle, or not?
So it's pretty new. I'm gonna speak like I'm an expert and know what I'm talking about, but this is really only an assumption on my part, right? Because I haven't used one of these either. My assumption would be that no, it doesn't absorb, no, it's not, it's not discharging the battery in any way. My assumption with it is that it's probably just connects those terminals together so that it seems like there's some kind of a load on it. The idea behind that plug is to just disable the movement of the vehicle. So it's going to disable the drive system the electric vehicles, if you're at a charging station and you plug it in, you're charging, right? And you're sitting in there on your phone, on your TikTok, watching Adelino dance his funny dances on TikTok, right? And then you see that you're fully charged up, so you just throw the vehicle in reverse and try to drive away. It won't work. If you're not paying attention and you try to drive away with the vehicle plugged into the charger, it won't let you do it. That's a safety feature that it has. So I think that's the idea of that plug, is that you're putting that plug in there to make the car think that it's being charged. So it just disables the part of the vehicle that lets it, the drivetrain, so it can't move. So the electrical danger would still be there. You'd still have to be cautious about cutting those orange high voltage lines.
All right.
I see somebody just threw something into the chat about an incident at a charging point. It looks like there's a video, so that's cool. Thank you for sharing that in the chat with us. Any other questions that I can make an attempt to answer for you all about? Once again, this isn't just it's not just electric vehicles that we're looking at. The same issues for that type of battery in the electric vehicle you're finding, once again, all the way down to the little, vaping, smoking devices, to your cell phone. Your cell phone's probably got a lithium ion battery in it as well. What we see a lot here are what they call a hoverboard. It's like a little two-wheeled thing. The kids stand on it and move their feet, and it zooms them around. I should get my son to hop on his and zoom around for you. He's got one, right? Electric bicycles, people are plugging these things in and walking away from them, leaving them on the charger for too long. And that's the other thing, is if people are using chargers that didn't come with a device. So if the device is reliable, right, that uses these batteries, be it electric bike, the hoverboard thing, whatever, if it's made by a reputable manufacturer, so if it's not, cheap Chinese junk, right, if it's somewhat decent, it should come with a charger that the charger would turn itself off when the battery's charged, and that would prevent that thermal runaway from taking place from overcharging issues, right? Where it comes into a problem is then you lose that charger, so you go online and you buy a cheap one, or you go to the store and you buy one, or let's be honest, in Africa, sometimes we get very creative with how we source our power, right? And so we're stripping plugs off and we're sticking wires into outlets. Okay, we all have seen this. Maybe we've all done it, right? So using something that we've somebody's put together, not the original charger with it, that can also cause those issues of the overcharging and causing that thermal runaway. Kindly repeat the effect of high temperature on the battery from hot areas. That's that thermal runaway as we expose those batteries to fire and we heat those batteries up. That begins that chemical reaction. It does two things. It starts to promote a chemical reaction within inside the battery. It's going to cause that thermal runaway and cause the battery to start generating its own heat. And then the same effect that we have anytime we expose any material to heat, it begins to off gas, and those gases that are put off by heating that material, most of the time, those gases that it's off gassing are toxic they are flammable. They are going to be fuel for the fire as well. So anytime we're heating a battery up, we're starting it in the off-gassing process, and we are encouraging it to get into that thermal runaway situation. At this point in time, I'm about to stop the recording for our official class. Let me just thank you all for joining me today for the class. I hope you got something out of this. I hope that that this went well, and you learned a little bit something about these batteries. Stick around. We're not finished just quite yet. Watch for your certificates if you stayed along for long enough. If you stick around, I didn't have time to do it today, but I'll put some information in the chat, some links where you can get to our Google Drive as well. So thank you all for coming, and we will see you all again next week.